we're going to look at how the sampling of sound affects the quality of the sound that we try to digitally reconstruct. If we have a sound wave, like an analog signal that we're trying to reconstruct, we need to sample it in such a way that it reconstructs this wave, the signal, as close as possible. If we sample it at a low rate, then we're not able to fully reconstruct this signal. So let's just show this by example. So if we sample it at a pretty low rate, let's do it like this. So we're sampling at regular, roughly regular, as far as I can make it. It's roughly the same. Roughly the same. So if we were sampling it at not a very high rate, and we tried to reconstruct the signal now, we'd have something like this. So what you've noticed is that all this high frequency here, in this part here, has actually not been represented at all by our sampling rate, because we've been sampling it at too low a rate. So we've kind of missed out all this high frequency part of the signal here. If we wanted to capture that, the most straightforward way of doing this then would be to sample it at a higher rate. So we can do that. So we can more closely construct the original signal as possible. So we sample it at a higher rate, and then we're able to capture much more of this high frequency signal if we're sampling at the higher rates. Do that. Okay, so we've got those there. And if we were actually to reconstruct that, then it would much more closely follow the original sound wave. So it would actually represent a high quality sound for us digitally. So there is a theory. So Nyquist's theorem states that you need to sample at twice the rate of the highest frequency. So that's a guideline on how regularly you need to sample, or what your sampling rate should be.